Right. So we have just discussed about the solar system and it's basically its basic structure, how planets are there and what are the relative sizes of the planets, and also basically the sizes of the planet, distance of the planet, how many moons are there. So likewise, we have just discussed about them. And so then actually how this system, so how the structure, how this system is working, you can just do the small practical and understand it. So we have to use like small ball. You have to just take a strain around like 50 centimeter. It's okay if it is more than that, but you have to put more effort then, right? If it is 1 meter, like then you have to put more effort. So what you need to do is you have to tie the ball. It's like this. So if there's a ball, like this, and you have to tie it first. So maybe you can use a tennis ball, something, or even the rubber one is also, but okay, but it's difficult to tie. That's why just tie it like this, and then use this string. And then what you need to do is take the other free end, and you have to rotate the ball fast enough above your head. So you have to rotate it, and this is you, and you have to take one side and just rotate it around your head. Then you can see when it is rotating like this. So normally it should fall down. Normally the ball should fall down because gravity is there. Gravity is there, so it should fall down. But when you're rotating this in a constant speed, you can see that, so this remain in the same level without falling down, remains in the same level, even though the gravity is there because of the force that you are putting in. So this ball will not fall down. Similar to that, so here you can like see, if you are, this is a simulation. So this center point is you. This center point is you, and that is the sun. And the force is basically the gravity, right? The attraction. The force is gravity, and this ball is the planet. So because it is rotating in a constant speed, it is not falling down. So that is what happened there. But so one thing, if it is like too fast, there's a possibility to this to move away from the actually. So the force will no longer be like able to keep that planet stable if you are rotating too fast. But if you are rotating, if the rotation is too slow, then it will fall down. So similar to that, because of this constant speed of rotation, it remains, and it remains without falling down because of this constant speed, right? Okay, right, that is it. And then now you understood what is the logic, how this system actually is stable, how this system is stable, how it is moving without falling down. So now you know this with this practical. This is the force. Okay, then so we have just discussed last day. I think we have just discussed about this thing, how these seasonal changes are occurring because of the northern pole and southern pole. There are seasons: winter, autumn, summer, spring. So these seasons are there. How this is happening, we have just observed. Actually, so let's see the example given in the book. So see June 21. In June 21, right? In June 21, you can see. So the sunlight is directly falling into the northern part of northern pole. Here, sunlight is perpendicular, it's directly falling into this northern pole. But so to the southern pole, you can see it's not direct, it is indirect. So this can be the hot season for the northern pole and the cool season for the southern pole. Because of this 23 degrees tilt, this happens, right? Because of this tilt. Otherwise, this won't, right? If it is straight away like this, then both southern and northern pole will get the same strength of sunlight. If it is perpendicular, make a lambako තිබ්බනම් මේ northern pole එකටයි southern pole එකට එක ගාන තමයි sunlight ටිකක් අඩුවෙන් තමයි වැටෙන්නේ. හැබැයි එක ගාන. හැබැයි මේ angle එකකින් හින්දා තමයි මෙන්න මේගොල්ලන්ට ග්‍රීෂ්ම ඇවිල්ලා මේගොල්ලන්ට ශීත ඍතුව. ඒ කියන්නේ හේතුව මෙයාලට වැඩිපුර රස්නේ දැන් කෙලින්ම ඉර එළිය වැටෙනවා. එතකොට පැය දවසේ පැය වැඩි ගාණක් ඉර එළිය මෙයාලට තියෙනවා. Right? Normally it is not 12 hours. It can be more than 12 hours. And then you can see the northern pole they don't have sunlight for few days. දවස් කීපයක් sunlight හරියට නැත්නම් ඉර ඈතින් ඇවිල්ලා යනවා. ඉතින් සීත කාලයක. So see December 22 it's reverse, right? When December 22 you can see the northern pole is not going to get in the sunlight, but the southern pole is getting the sunlight very well. Northern pole is not reaching, but southern pole is getting the sunlight. This is how the seasons are happen. We should explain using this diagram. Okay, then actually occurrences of phases of moon, different phases. Phases means you can see. So if you observe the moon different days, if you observe the moon in different days, you will see different phases. Apikina Chandra Kala, different phases. So that means the visible area is different from day to day. The visible area is different. Why this is happening? So why this difference is there? Why this is happening? Right? We need to observe on that. Okay. So let's do similar experiment that we have done, but this time we have to use a light. Right? So according to in your book, this experiment is mentioned. Yeah, we have to use a light source. Maybe you can use a bulb and a regiform or this stereoform, stereoform ball in the middle. Or maybe you can use a plastic ball, that doesn't matter, right? And what you need to do, you need to rotate this ball around your head. This is Earth, right? Earth is you. This is Earth, Earth is you. You have to rotate this because moon is moving around you. How many days it takes to move one circle? Yes, to move one circle. What's the duration? To move and come to the same position? Yes?
1 day.
1 day? Within 1 day, can it come back to the same?
What, sir?
Sorry? Actually, Earth is rotating around Earth. පෘථිවිය එයාගේ වටේ එක දවසකින් කැරකෙනවා පුතේ. Earth is rotating, that is true. But moon හඳත් පෘථිවිය වටේ එක දවසකින් යනවද? එහෙමනම් දැන් එහෙම වුණා නම් කොහොමද දන්නවද අපිට පේන්න ඕන? අපිට හැම වෙලේම හඳ පේන්න ඕන. ඇයි? දැන් අපිත් අපේ වටේ එක දවසකින් කැරකෙනවා. ඒතර හඳත් අපේ වටේ එක දවසකින් කැරකෙනවා. If it happen, මෙයාටත් 1 day නේ යන්නේ මෙහෙම ගිහිල්ලා පොරොමක් එන්නේ. ඒතර අපිට මෙතන ඉඳන් කවුරුරේ හඳ දිහා බලාගෙන ඉන්නේ. Right? ඒතර මෙයා කැරකිලා එතනට මෙන්න දවසක් යනවා. Within 24 hours it rotate and come back. එතකොට හඳත් එයා වටේ ගිහිල්ලා මෙතනට ඇවිල්ලා එන හැම වෙලෙම මෙයාට මොකද වෙන්නේ? හඳ පේන්න ඕනනේ. එහෙම වුණා නම්.
Yes.
එහෙම වෙන්නේ නැහැ නේ. Right. Then how many days?
28 days.
Closer to 28, 27 point some, right? Closer to 28 days, right? That is what the moon take to rotate around us, right? So then you can rotate. When you rotate, you can see some, like when you are straight away, when you place this straight away to the sun, even sun is bigger, moon is closer to you now. Because of that, the shadow will fall and you will not see the moon properly because you will see the shadow side of the moon. So that is basically when the moon is totally disappearing. But when you're rotating, so one time you will see the full light side of the moon. But some other times you will get half light or quarter light sides. And so this you can photograph. Okay, this you can photograph. Okay, here the Wednesday you cannot see the full moon. It is 99% visible. And then in the Thursday, you can see full moon. Everything is visible. That means the full light is falling into the sun. And you can see that. So then you can see this side is fade away. This side is fade away. Slowly, 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 slowly. Now this is half. You can only see the half. The other side is dark. Here you can see less than half. And then you can see very thin layers. And then 16th, it is fully invisible. It is visible actually, but the thing is, the light is not falling into that, therefore you will not see. That is like a blank. And then it will slowly appear in here, slowly appearing back. And then it will become full moon. This happens within 27 days. This happens within 27 days and 27.5. Right? So that is basically how it is happening. And you can see here, this is the moon. This is the moon. Let's see, there is interactive animation. Let me show that to you. I think you can get a proper idea. Okay, so before that, let's learn about these eclipses also, right? Eclipses also. This is some interesting phenomena happening, right? Solar eclipses and lunar eclipses means the moon. Solar is sun. Eclipse. So there is a like these two eclipses are so like here you can see the moon revolves like 27 point. The revolution time is moon 27.3 for moon. Okay, how solar eclipse happen and how lunar eclipse happen? So which is more common? Is it solar eclipse or lunar eclipse? Which is more common? Yeah. Is it solar eclipse or lunar eclipse? Yes. Frequency of solar eclipse and frequency of lunar eclipse, which you can see more times.
Lunar eclipse?
Yes, it is lunar. The reason is because solar eclipse, so in order to solar eclipse to happen, you have to wait years. Full solar eclipse, but they are like half and partial eclipse. Okay, this is how solar eclipse happens. Sun is, it's bigger, right? It's a bigger object, but Earth is relatively smaller than Sun. And then you can see here the moon, right? So the shadow of the moon, basically, when you're directly, if you're here, you cannot see sun because of the moon. It is fully covered. So this is where the eclipse happened, right? Here. So see the description. So some occasion, the shadow of moon falls on the earth. So this can be full shadow. If it is full shadow, then you call full eclipse. Right? We see sun and the moon in equal size in the sky, right? The reason is what? Because sun is far from us, but moon is closer. Therefore, so sun and moon relatively equal size. So therefore moon can cover the sun. Otherwise, it is not, right? Because if both are in same size, if both are in same size and the same distance, then it cannot cover it, no? So even this is a small object. So if it is closer to you, you can see it much bigger. So that is what happened in here. Okay. So sometimes you can see. Have you seen eclipses? Solar eclipses?
Yes, sir.
When? Can you remember?
In 2018.
2018. Is it full or half?
Half.
It is partial, right? Okay. Then those who are in the this is called umbra. Those who are in the umbra, and this is called penumbra. In the penumbra, you'll get a shadow, right? Like partial shadow, but here you'll get a full shadow. Those who are in the umbra can see the total solar eclipse, but those who are in the penumbra can see the partial solar eclipse. So I think, so then we were here. So we couldn't see the full one, but we saw the partial. Okay, in the total solar eclipse, you can see the sun is fully covered. And then if it is annular solar eclipse, so it happens here, right? In annular solar eclipse, still you can see the shadow, but so surrounding the sun will be visible. In the partial solar eclipse, you can see part of the sun. Actually, if you observe shadows during the solar eclipse, what will happen to the shadows? Have you seen?
No, sir.
It will looks like exactly like this. Shadows, okay, not the shadows actually, the color patches. අර ගස් අතරින් එහෙම වැටෙන්නේ දැකලා තියෙනවා.
Yes, sir.
right. Okay. ගස් අතරින් අර රවුමට නෙවෙයිද ෂැඩෝ එක වැටෙන බින්දු වැටෙන්නේ අර රවුන්ඩ් තියෙන්නේ වැටිලා ඉරේ එළිය ෂැඩෝස් නෙවෙයි ඒක අනිත් පැත්ත නේද? එතකොට ඒ ලයිට් ඉරේ එළිය බින්දු වැටලා තියෙන එක පුතේ ඔයාලට පේන මෙහෙම අඩකවයක් වගේ. ඒ වෙලාවට. Right? So, yes, see. Light pressures during solar eclipse. පින්තූර නම් දාලා නැද්ද මදා මේ තියෙන සමහරට මේ තියෙන. Haven't you seen something like this? Yes. මතකද මෙහෙම එකක් දැක්කා?
Yes, sir.
Right, okay. So during that, because this is partial, right? During that partial, you can see the shadows like this. Okay. So let's see how they are happening, right?
Okay.
Okay, actually, Sri Lanka experienced total solar eclipse in 1955. You were not there, and I was also not there, right? In 1955, right? But we can always browse for the history. As you said, in 2017 or 18, I'm not remember exact year, but it happened. Solar eclipse. So let's see whether your book is telling truth or false. You can search. So yes, according to that, this is 1955, right? And that is what the recorded one is, but annular one is in 2019, right? Annular solar eclipse in 2019. I think it's 2019. But 18 on the annular solar eclipse. It was 2019, it seems. Next one will be this 5/21 2031. We have to wait some years. 2031 තමයි ඊළඟ එක එන්නේ solar eclipse එක. The previous one was, I think, 2019, right? 18? It happens in 18, I'm not sure. No, it's 19, right? 19.
Okay.
December 26, 2019 seems, right? In Jaffna. Not visible, not fully visible to us, but in Jaffna, they could see this one. They have seen this one. Okay. Come back. So this is the experiment. You can just read it out. So how the 2050, 1955 one was happening. And observing can be done in several ways. One thing is you can use you should not look at the sun because it is really powerful. You should not look at the sun using naked eyes. But you can use there are special goggles or eye covers, and also we can use mirror or a telescope. So this is actually a mirror telescope, a different one, right? You take in the image on to screen using a telescope, or you can use a water basin. 2019 was an annular one, and 2020 also an annular eclipse was there, right? 2020 also there was an annular eclipse. And here using Google's, and there is a primary method. You can use this carbon emitted using carbon layer, which is emitted using the fire, when you're firing firewood. So you can just shade a glass using that carbon and then use that. Delhi වලින් මේව කරපු එකක්, carbon Delhi වලින් වහපු මේව එකක් අරගෙන එහෙම බලන්නත් පුළුවන්. So that is the primary method, but there are Googles, special Googles, and also you can use maybe water basin to see the reflection, but some reflections are dangerous. So if it is happening in the noon time, yes, okay, but if it is happening in the morning or during evening, you should not look at that even using this water basin. So I have explained the reason in previous classes, but if you cannot remember, let me show that using this light reflection. Just wait. Okay, see that, right? This is actually, you can see this is a light ray and or light wave, whatever it falling down. So there is a refraction, which is like, this is, you can see water. Refraction means going down to another transparent type of, but two media. So the first media is air, the second material or second media is, you can see it's water. So it's falling down. Refraction is which is going down. But there is a reflection also. Reflection means which is returning back. So to the AI, you can see here 8.23%. If a solar eclipse happened here, so whatever comes to the eye to the reflection is only 2%. So you can watch that using the water basin. That is not that much dangerous. But if it is happening somewhere here, so you can see the intensity is high. But assume that the this solar eclipse happening somewhere here, then the reflection is closer to 41%, and that is really, really not good to look at that using the reflected water basin. Understood why it is not good? Because when it is in the angle, the reflection is really high. Understood?
Yes, sir.
Okay, but if it is in the top, in the noon, the reflection, direct reflection is very low because refraction is high there. Okay, that's the point.
Okay, sir.
Okay, then what is lunar eclipse? Solar eclipse is where you can see here you and Earth and the Sun, Moon come in between. And then the lunar eclipse is where Earth come in between. Right? Here you can see the Sun and Earth is here and the Moon is here. When Moon is here, the Earth's shadow will fall into Moon. See, like it is really far away from us, but anyway, the Moon shadow will fall on us, and similar way, Earth's shadow can fall into Moon. Lunar eclipse can occur on a full moon for a day. It can occur in its foyer or something, the full moon day. Right? So normally, that is why I said it is common because every month there is a full moon day. So rarely, in some months, the lunar eclipse can happen. A full moon day and the moon is not there because of the shadow of the earth. So that is the moon. So that can also be again penumbra or umbra. Penumbra or umbra. So if it is umbra, it is fully covered, but if it is penumbra, it is a shadow, right? So this is how it is visible. So actually, moon is visible, but the light of the moon will be very, very. So maybe you will not see the moon. It will be very, really dark, and sometimes a shadow can be seen. Yeah. This is total lunar eclipse. If you're in umbra, you can see the full shadow of the earth is falling into the moon. So it can be total, partial lunar, or penumbral. Penumbral means the shadow is. So then the brightness of this will be less. That is the idea. The brightness of the moon will be less. But if it is umbra, the brightness is very, very low. Okay, here you can see. But this is the partial lunar eclipse. Difficult to observe. Like partial lunar eclipse, it is, yes, it is possible to observe, but so that should be a full moon day. Otherwise, you will not think this as a partial lunar eclipse. You will think this is normal moon. But if it is happening the full moon day, then part of moon displayed in the full moon day, yes, that is the moon. But penumbral one is quite difficult to because it is not producing the considerable amount of light. So sometimes it's difficult to observe. So the brightness of the moon will be low, but how can we compare? We cannot remember the brightness which was. So therefore, it's difficult to identify the penumbral one. Okay, this you can see in between you and, so the solar eclipse in between you and this Earth and you, actually moon can come between, then you can see this solar eclipse, and when Earth is between you and the moon, then the lunar eclipse happens. Okay. Are you clear on this? So I will
Yes.
share you two links. I will share you two links. This is to see. So you can see it in my screen too, but for your understanding, I'm sharing you the links. You can go and explore these links too. Okay. This shows solar and lunar eclipse both, and how this happens. You can see the shadow of the moon is falling into the earth, so it will cover the. So that is the solar eclipse, right? That is solar eclipse. And when it is other side, the lunar eclipse can happen. Earth's shadow is falling into the. So let's see the lunar one. But this, in order to this to happen, the moon should move to the other side. Now Earth's shadow is there. So let's see how lunar eclipse happen. It can happen in a full moon day. Then only we can observe very well. Otherwise, no way to follow the shadow also. Both should be indirect. Okay, now we can see here. Okay, this is how a lunar eclipse can happen. Another link to observe this lunar and solar eclipse is this. This is another link that you can use. Please remember these two links. It's very important. You can see here. Penumbra and umbra, you can see here. Okay, it's penumbra. And you can see umbra also. But this penumbra one is very, very difficult to observe, right? Penumbra one is very, very difficult to observe. The reason is because you will not notice the brightness of, moon. You can see the shadow is falling. Okay. Now the red color. Okay, disappeared. Okay. In the different orbits, the redness can be, so this second orbit, can you see? The redness is varied. The third orbit is moving little up. And I think you can see the dark part in the here, in the bottom. Right? This is what the lunar eclipse and solar eclipse is also. They are in the same Media Sciences one, right? So this website you can browse for the you can search for the solar eclipse. Okay, let's move down there. Okay, people were really interested in what is happening around. So basically, in our atmosphere, there is our air layer. It is around 500 kilometers from the surface of the Earth. ලොකු වායුගෝලයක් අපිට තියෙනවා. කිලෝමීටර් 500ක් විතර අපෙන් ඈතට යන වායුගෝලයක්. Right? But after it becomes very thin after 100 kilometers. After 100 kilometers, the layer is thin. It's not that much pressure. So it is cool and thin when after 100, but it is around 500, right? So then actually scientists, they wanted to explore this and they were trying various mechanisms, and these are some experimental and also things that they have used. So hydrogen or helium balloon. The reason is hydrogen or helium is lightweight. So do you know how to create your own hydrogen balloon? Yes?
No.
No. Oh my God.
No.
You're doing that practical for grade 4 kids also. Grade 4 නෙවෙයි, age 4 kids ලට අපි කරනවා ස්කූල් එකේ. හරිද? එහෙනම් මම පෙන්නන්නම් ඔයාලට අපි කරන practical එක. So this practical is there, right? You can just watch our channel and it is there, right? Stream. Let me show. You can use aluminium foil. Right? Straight that thing. You can use aluminium foil and sodium hydroxide, caustic soda, aluminium foil, and this one, hydrogen balloon, kids practical. Can watch this, right? These kids are also doing. You are in grade 8 means you need to do this anyway. This is not difficult. So you can find aluminium. You can get aluminium foil from a supermarket. කරලා බලන්න. හරි සුපර්මාකට් එකකින් ගන්න පුළුවන්. මොකද ඇලුමිනියම් ෆොයිල්ස් වලින් තමයි අර කෑම හැම ඔක්කොම රස්නිට තියෙන්නේ. ඒ සුපර්මාකට් එකකින් ගන්න පුළුවන් ඇලුමිනියම් ෆොයිල්. Okay. Within aluminium foil. The aluminium foil පුංචි කෑලි වලට ඉරලා අපි වීදුරු බෝතලයකට දානවා. So see, they are inserted that to glass bottle. Then the sodium hydroxide solution. Caustic soda මේවත් ගන්න පුළුවන් hardware වල තියෙනවා. You can put caustic soda solution. එක දිය කරලා ගන්න ඕන වතුරේ. Caustic soda into this and then put the balloon. But you have to be careful. Sometimes this this bottle can be very hot. So you have to keep this bottle in a water basin. වතුර බේසමක තිබ්බොත් හොඳයි. මොකද මේ reaction එක වෙනකොට ගොඩාක් රත් වෙන්න පුළුවන්. Here it emits hydrogen, right? It fills the balloon. And hydrogen, when it is filled to there, hydrogen is lightweight, so the balloon will move up. Here I have used a thread එකකින් පාස් මේ අල්ලගෙන ඉන්නේ. එහෙම නැත්නම් ඔය වගේ යා move වෙනවා. It will move up. Right? So see how fast that is. And you can use a very large hydrogen or helium balloon, but very large one, right? මේ වගේ එකකින් චූටි balloon එකකින් අපිට උඩට යන්න බෑ. But you can use a very large hydrogen balloon. Or helium balloon. Helium is better because hydrogen is anyway, again, it is used as it is inflammable, right? It can blast. Gini ganna puluwan hydrogen. Or indhanayak widiyatath pawichchi karana. Therefore, helium is better. Helium is not that reactive. So if you can use helium balloon, then yes, using the helium balloon, you can. So this is what, and this hot air balloon is also there. So this experiment you can get if you visit Sigiriya in Sri Lanka. Also hot air balloons are there. You can get that experiment. Okay.
Okay.
Hot air balloon එක ඒ වගේ ගිහිලා තියෙනවද hot air balloon ඉස්සලා?
No sir.
Sigiriya පැත්තේ තියෙනවා. තියෙනවා අපේ ලංකාවේ තියෙන hot air balloon එකකට ගෙවලා අපි ඉන්න බලන්න ගණන් කොහොමද කියලා. දඹුල්ලේ තියෙනවා. ගිහිල්ලා අම්මත් එක්ක හරි තාත්තත් එක්ක හරි යන්න කට්ටියම ගෙදර. නිවාඩු දවසක් දාලා. Right.
Okay.
Hot air balloons in the Yadamulla, it's there. So it's much expensive, it seems, but it is $260. 6 a.m. වලින් ගිහිල්ලා 1 hour balloon flight fees, celebratory campaign, juice and water. Hotel pickup and drop off, food and drink, additional fee for pickup, out area. Okay, $260, right? Nice one, right? You should try this. $260 means it's a bit expensive, but better try this time. Okay, Mute. So these are some experimental and the rockets and satellites. This way.